Okay. So we have these two equations. Well, I'm going to go ahead and substitute numbers. Oh, that's that cloth. Come on. How to be able to substitute numbers for symbols here. Of course, I'm probably going to get something different than you got, but you get the idea. Exactly. You know, it's a simple fill. Okay, so let's just say these are my two equations. Now I could. Yeah, I'll do. I have to do something a little different than what we did, but. Remember, you understand what I'm doing here? I'm indicating the operation I use on each row or on each equation. And we do 5 times equation 1. You want to write that out to the side and make sure you've got it right. But I multiply both sides of this equation by 5, and y'all are doing that just fine. Okay, then I multiply both sides of this equation by 2. I'm going to change that. I'm going to multiply this by -5 to get a minus 10x, which I should have done in the first place. In here, I'm going to multiply the second equation by 2 to get 10x plus 6y equals 28. Then we're going to add the two equations. Add the first equation to the second, and I'm going to get 41y equals 67. So y equals 67 over 41. Now I can plug that back into either of the first two equations. Do that rather quickly because I think everybody understands that process. So we take this. And just plug it into the first equation. What we get is 2x minus 7 times 67 over 41 equals 19. So that's going to be 420 and 49 is 469. Over 41 and so forth. And multiply both sides by 41. We don't have to get confused by the fraction. And I think my brain's in fairly good shape, but I don't want to test it by doing those multiplications. So what the heck I'll do. You get you're going to get 81x minus 469. That's going to be equal to 41 times 19. Now 41 times 20 is 820. You subtract 41, you get 779. that makes sense. Should be closer to 800. 820. Yeah, that's what I got. I think it is 81x equals. Maybe that's 1248. I think maybe it is. So the X would be 1248 over 81. I think could do prime factorization. Or you could just see that, well, 3 goes into this and this. Easy to see 3 goes into 1248. 81 is just a product of 3s. So if you just keep dividing by 3s, you can't do that those 4 times, and you're going to either get a reduction or you're going to know that you don't reduce anymore. Okay. So if you do prime factorization of this and this, you can see which prime factors divide out and get your result. 9, 380. You're just going to get one position. Okay. Well, that's process of elimination. If you got 3 equations, well, you can reduce the 3 equations to 2 equations by eliminating one of the variables. And that's a pretty standard process. And I assume we've been through that and done some of those. We've done examples. So I want to move on to the matrix representation of a system. And talk about how we can solve the system using matrices. There are little bits of differences, but it's very much analogous to this. Okay, so I'm going to take this system. I'm going to put it between square brackets. I'm going to put a little dotted line here. Okay, do we see how these numbers represent these equations? If we simply understand that this is multiplied by x and this is multiplied by y, and this is an equal sign here, it's just a shorthand for the entire equation, because we don't really care about what our variables are. We're operating on the numbers, and the variables are just there to keep everything straight. Well, the variables have other importance too, but as far as the process of solving it, we could regard it as that. If this was a Q and this was a P instead of an X and a Y, our steps would be exactly the same. We just have Q's and P's wherever we have X's and Y's. Well, we make a little note just right now. Pretty soon we this stands for this multiple of X and this multiple of Y equals this number. And this row stands for this multiple of X, this multiple of Y equals this number. We have row 1. Now there are other different ways of designating these, but I'll just use 1 and 2 for rows 1 and 2. Now watch how I solve this. I'm going to do something a little different than what we did over here. Now I'm going to start by doing what we did over here. Then I'm going to do it a little differently. Okay. So what did we do here? We did -5 times equation 1 and 2 times equation 2. Well, if we just do -5 times row 1 without even looking at the x's and the y's, -5 times 2 is 10, -5 times -7 is 35, and -5 times 19 is -95. Uh-oh, Over here, this is a negative 67, isn't it? This should be a negative 67. Yeah, so this should be a positive, this should be a positive, which is gonna change my number here. So I'm just gonna kind of erase all this over here. And just put it center here. Okay. Now we corrected that. Back to the idea here. We simply do the same thing to these rows that we did to these equations. We're going to get something that's going to represent our solution. Okay, so 2 times the second row, just looking at the numbers now, we have 10, 6, and 28. And let's actually be negative 10. Okay. Got all my signs right. Okay, then I'm going to repeat row 1. Row 2 is going to become my old row 1 plus row 2. Going to give me 0, 41, negative 67. Okay. Now, when I do row 1 plus row 2 here, I'm always going back to the rows in this matrix. I don't want to confuse the row 1 here with the row 1 here. The row 1 that I use here is the one that I have up here. Of course, since it's just repeated here, it doesn't matter, but that can make a difference. Okay. Then what I do is I repeat row 1 and I do row 2 divided by 41. I get this. And this. Now, what does this stand for? This stands for x equals negative 67 over 41, which of course is the same solution we got here. Difference is I'm still keeping both of my rows here. I don't change. I mean, I always keep both rows. Okay. What I can do next is okay. I'm going to add row 1 to 35. Well, I'll do minus 35. I'm going to add row 1 to negative 35 times row 2, or I'm going to subtract 35 times row 2 from row 1. Okay, so I'm going to get negative 10. Now, negative 35 times row 2 is going to give me a negative 35 here. And that's going to be added to the 35 to give me 0. Then I'm going to do negative 35 times negative 67 over 41 and add that to negative 95. I'll get negative 95. Write that just a little lower. Okay. Now that's something we want to look at carefully. Again, if I'm doing negative 35 times row 2, that's going to give me a negative 35 here, right? When that's added up here, it's going to give me 0, and that's why I chose negative 35. It's really easy to see what I have to multiply by this row and add to this if I want to eliminate this. Then I got to do negative 35 times negative 67 over 41, which is going to give me positive 35 times negative 67 over 41. I'm not going to write that down in my second row because I like my second row the way it is. It tells me y equals this, right? But using that, I can see what number I have to combine with this. A negative 35 times negative 67 over 41, it's a negative, and a negative, that's 35 times 61 over 41 is positive, okay? So that gets added to the 95. I've got 0, 1, negative 67 over 41 here. Then all I do is divide this row by negative 10 to give me 1, 0, and all this divided by 10. And that's something you can just plug into your calculator. Okay, now I don't have room to, getting pretty low on the board. This expression is going to be a little messy, but I want to keep this part of the board. So I'm going to go ahead and write it out. I'm going to get row 1 divided by negative 10, and then row 2 is just going to be repeated. If I divide row 1 by negative 10, I get 1, 0. Then I get I got carried away with my bracket. And the last expression, so I'll take my bracket there. Put a little line here, separate this matrix from this matrix. So I get all this divided by negative 10. Makes it a little hard to read. And I get this. Trying to see if that's still visible. Okay, I'm going to lower the camera just a little bit. I don't like it, but. Okay, there we go. Okay. Now again, it might be a little hard to read. The point is, it's pretty easy to write out all this. I didn't have to do the arithmetic. I didn't have to solve the equations. I just had to write out the expressions. Now I can take my calculator And if I wanted to evaluate this, I'd approximate it in my head. Then I'd certainly use a calculator. Going to give you something like 6. That's going to be something like -1.5. And there I have it, okay? So when you get used to doing this, it can actually be easier than dealing with the equations with the X's and the Y's. So we're going to practice doing this. I'm going to give you another matrix and ask you to do the same thing with it. I'm going to make it fairly easy this time. Okay, first of all, there's a matrix. So write that down, and then off to the side someplace, write down the equations that that matrix stands for. Okay, everybody wrote the equation out correctly. I don't really have room. You've got the equation. Maybe I'll eventually write it at the end, okay? And that one isn't going to take many steps. Okay, my next goal is to effectively eliminate X from the second equation. Okay, so the question though, in terms of the matrix is, what multiple of the first equation would you add to the second to get a 0 here? Okay, would be -3, right? If you do -3 times this and add to this, it's going to wipe out the number here. You're going to end up with a 0 here. So we're going to do 1 and 2 minus 3 times equation 1. I should have these better lined up. I didn't anticipate all. And you're going to get a matrix. You're going to get some numbers. The one thing I'm going to tell you is you're not going to multiply equation 1 by 3 here. You're going to keep equation 1 exactly as it was. But then you can do it in your head. If you multiply each of these numbers by 3, then just like multiplying the whole equation by 3, you can multiply these numbers by 3 in your head and add them to these numbers, but negative. You multiply by -3 and add them to these numbers. Now, if you want to write it out to the side, if you want to write that calculation out to the side, it's okay. But keep things lined up here. And while you're doing that, I'm going to line up first matrix with the second. Remember what matrices are. Okay, did kind of dead space in the camera while I did that, but there it is. Okay, I should have left myself room over here to parallel what we're doing here with the equations to make sure that we're really connecting it. So if you love the side of this whole column here, take a good look because it's going to go away. Okay. Okay. So what this stands for, of course, is x plus 2y equals 5, 3x minus 4y equals 2. Okay. Now, this still stands for x plus 2y equals 5. So I'm going to write over here, though, what we get. Okay, if this is 1 and this is 2. Negative 3 times 1 is negative 3x minus 6y equals negative 15. Place on that chalk. And then if we had our second equation, it would be 3x minus 4y equals 2. And when I add these two, I get just plain old 0x minus 10y equals negative 13. Okay. I don't have to write all that out though, either in my head or physically. I could write out this row. Okay, so instead of 1, 2, 5, I could write out negative 3, negative 6, negative 15, and then the second row 3, negative 4, 2, and add those, and I get 0, negative 10, negative 13. Okay. Now, this calculation is just the same as this. I've just left out the x's and y's and equal signs and kept things in order. Got to keep my numbers in order so they don't start to mean something if they don't. Okay. Now over here, I'm doing 2 minus 3 times 1. Okay. Row 2 minus 3 times row 1. Okay. But what's minus 3 times row 1? Go up here, make sure I'm looking at the row in the matrix before. Negative 3 times row 1 gives me a negative 3 here. And I'm going to add that to row 2. Negative 3 and 3 gives me 0. So I don't have to look at this. I don't even have to think about this. I just look at this row and think about what happens if I multiply this number by negative 3 and add it to this one. Okay. Well, then I do negative 3 times 2, which is negative 6, right? And add that to negative 4, that's what gives me the negative 10. And then again, negative 3 times 5 is negative 15. Add 2, I get negative 13. Now, here's what it means, here's why it works. Here's explicitly how the rows would add up. But the difference is I never write out this equation. I never write out this row. I keep row 1 the way it is. I like row 1 the way it is. The reason, something I don't like, the reason I like row 1 the way it is I have a 1 that stands for just a 1x, right? Down here I have this. Well, next thing I want to do is I want to see what y is. So I've got row 1. I've got row 2 minus 3 times, well, sorry, we're going to do row 2 divided by negative 10. So row 1 is still going to be 1, 2, 5. Row 2 is going to be 0, 1, 13/10. And this stands for x plus 2y equals 5 and y equals 13/10. I've got my solution for y, which unfortunately isn't what I thought I was going to get. Okay. Next thing I'm going to do is I'm going to do row 1 minus 2 times row 2. I like row 2 the way it is because I've got a 1 here. Meaning I've got just y equals. Okay, so Let's see. I could write it out over here. Maybe not a bad idea to do that. I'm just going to do row 1 minus 2 times row 2. Okay, let's see. Row 1 is give myself 1, 2, 5. Row 2 is 0, 1, 13. If I do row 1 minus 2 times row 2, okay, well, here's row 1. Here's minus 2 times row 2. I'm going to get to minus 2 times row 2, I'm going to get 0, negative 2, negative 26 tenths. And when I add them up, I'm going to get 1, 0, 5, minus 26 tenths. That's what I get if I write them out like this. I wouldn't write them out like this, though. I would look up here. I'd say, okay, row 1 minus 2 times row 2. The first column stands for my x coefficients. I've got 1 minus 2 times 0. And that gives me 1. And then I've got the number in row 1 minus 2 times the number in row 2. Well, what's that going to give me? It's going to give me 0. Because I've got 2, and negative 2 times 1 is negative 2. And I add those up, I get 0. That's premature when I wrote the bracket here. Then I do row 1 minus 2 times row 2. That's going to be 5 minus 2 times 13 tenths. And that's I'll write it out this way. So that's row 1 minus 2 times row 2. Then I get 0, 1, 13 tenths. This stands for x equals this, y equals this, and that's my solution. Now, of course, I can do 5 minus 2 times 13 tenths. At this point, I just say, okay, so x equals this, y equals this. If you want a decimal expansion, you just take this in calculation, plug it into your calculator, but this one's pretty easy to do. 5 minus 26 tenths. If you want to go to decimals, it's 5 minus 2.6, which is 2.4. So you could say x is 2.4. Y is 1.3. It'd probably make open math happy. And make me happy if you also do the fractions here. You got 50 over 10 minus 26 over 10, which is 24 over 10, which is 2.4 coincidentally. Okay. And make yourself happy by being able to do with fractions or decimals. When you get into something like what we got over here, fractions probably aren't going to be that meaningful. Theoretically, you should be able to, well, you should be able to do the fractions. But when the fractions get that ugly, you can't really visualize what they mean anyway. Okay. So calculator, used judiciously isn't such a bad thing. Now, if we master this process, it becomes easy to get a solution. Now we've got a question, means I probably made a mistake before I substitute these in and see if they work. I'm going to substitute them in before I answer your question. Okay, let's see. We got 2.4 and 2.6 is 5. First equation satisfied. That's 7.2 minus 5.2, which is 2. Those are correct. Okay, so if you think I made a mistake, you're wrong, but go ahead and tell me anyway. Okay, so the one question I had, and it's totally valid, except multiples of 10 are easier than multiples of 5, so I chose to use 10. Just a matter of space. Yes, 26 over 10 can reduce to 13 over 5. Okay. If you see that this is 26 times 13 over 1 times 10, you can rearrange that as, well, you rearrange that as 2 times 13 over 2 times 5 and get 13 over 5. Or just reduce that to 13 over 5. The numbers get a little easier, but really 10s are easier than 5s. Okay, in this case, I'd have kept the 10s. Most cases I would have reduced. Okay, well, the whole point is know how to do the fractions. You certainly know how to do the decimals. If you save your calculation to the last minute, you don't put in a bunch of round offs. So you get the most accurate approximation. Because every time you round something off and then use it in something else, it gets less accurate. So writing it out like this is probably worth doing. If you just have to approximate things, go ahead. Just approximate them to a sufficient number of significant figures. And then later on in pre-calculus, we see what difference that makes. It'll be easy to transition, okay? Really what I want you to see is this process. Because it's a little bit unfamiliar, but it's really very easy. If you just keep your wits about you and remember what you're doing. So, with that in mind, I don't know if I've got, should have some more words here somewhere. Yeah, here. Okay, the other thing also. No, before we go on, I better get your fingers out, which is about all over. Okay, again, if I plug 2.6 and 1.3 in to these equations, it works. And it should work if I've done all this right. Everything I've written over here represents an equation that I could get from my original equations. I'm just adding multiples of equations to each other. Or sometimes I'm multiplying an equation or dividing it by a number. Okay? But I'm not doing anything that doesn't represent a valid operation on equations. So that this is equivalent to these equations, and these equations are totally equivalent to these equations. Okay, well, let's try another. Let's see if I can actually do something in my head and get one to come out with nice numbers. Okay, I'm trying to be nice to you, but yeah, it's just okay. Okay, let's see. I'm going to do. These equations. Put your circled numbers to indicate the equation so you can indicate what operation you're doing on each equation. Hint. I'm going to do the first step. I'm going to tell you what the first step is. So I want you to execute the first step and then proceed from there. So if you do these operations, equation 1 divided by 4 and equation 2 means you're going to write down row 1 divided by 4, then you're going to write down row 2. So show me what you get. Okay, now everybody's got this. Did that very well, quickly. Okay, well, if you look at where we started last time, we started with a 1 here. We want to start with a 1 here. So whatever this number is, we're going to divide the first equation by that number. Okay? So now we have a 1, so it's easy to figure out how to eliminate that 6. Because what did we do here? We had a 1 here. We used the fact that we have a 1 here to figure out what to do to get a 0 here. Getting a 0 here just eliminates x. Okay, so by getting a 0 here, and we did that how? By multiplying, we'd have to multiply 1 by -3 to get 0. No, if we have to multiply 1 by -3 to get the -3, we need to add the 3 to get the 0. Now, having multiplied this by -1, we've got to multiply the whole row by -3. Sorry, having multiplied 1 by -3, we multiply the whole row by -3. In our heads, we don't write it out that way, but that's what we're going to add to row 2 to get the 0. Now the pattern is, and then pay attention to this. We get a 0 here. Once we get a 1 here, we get a 0 here. And then we're going to be able to get a 1 here. And then we're going to be able to get a 0 here. So when we've got our 1 here, then our 0 here, then our 1 here, then our 0 here, we've got our solution. We just got to do it by multiplying or dividing rows by numbers. We divided this row by 4 to get the 1. Okay. Or by adding rows to rows. Okay, we're running out of time. We got about less than 2 minutes left. I'm going to go ahead and finish this. Okay. We have this. Now we want to get a 0 in this position. We've got a 1 here. We want to get a 0 here. How do we do that? Well, I think everybody sees that. You know, we're going to repeat row 1. We don't want to get rid of that 1. Don't want to do anything to this row that messes with that 1. Because we'll end up with an x equals something, and that stands for an x. Okay, we want to get a 0 here. How are we going to do that? Well, we do row 2 minus 6 times row 1. Okay. Well, okay, so here we did minus 6 times this. Well, this minus 6 times this. Okay. Well, then we've got to do this minus 6 times this, and this minus 6 times this. Okay, this minus 6 times this, that's 3 minus 18, which is minus 15. And this is 3, and minus 6 times -2 is plus 12. That's 3 plus 12, that's 15. Okay, so we got our 0 here. Now what do we want? We want a 1 here. We get a 1 there. We divide 2 by -15. And I write it out with the division sign, so I can write it out in a row. Take up this space. Okay, I've got 1, 3, -2, because I'm not messing with row 1 right now, and I get 0, 1, -1. If I divide -15 by 15, I get 1. That's why I divided by -15, so I would get 1. And then when I divide 15 by -15, I get -1. Then, what do I want? Well, I want a 0 here. Because what I want to get is I want to get 1, 0, 0, 1. That means x equals y equals. Okay, first equation, no y is left. Second equation, no x is left. So I have my solution. So wrote that one down in a bad place. I don't remember what I was thinking, it's probably wrong. Okay, we do 1 minus 3 times row 2. Because how am I going to get a 0 here? I'm going to do -3 times this row added to this row. Or 3 times this row subtracted from this row. I like to think of -3 times this row added to this. We don't have to worry about subtracting negatives. Okay. So -3 times 1 is -3 added to 3 gives me 0. Then -3 times -1 is 3. Added to -2 gives me 1. So my solution is x equals 1, y equals -1. And to review where this comes about. This equation would have an x-intercept of -2 and a y-intercept of -3/2. I think. And this would have an x-intercept of 1/2. And a y-intercept of 1. I'm not getting the graphs right, but the graphs would. One way or another, they would look like this, but the crossing point would be 1, -1. I'm doing something wrong in my head here. I'm getting the wrong intercepts. -2/3 would be 1 and still doesn't look like it works. Okay. Yeah, no, that's what we get. So remember, the reason I write this out, remember that these equations, these rows stand for equations that have graphs. And this is the crossing point of the graphs. So we come back to the whole graphical picture.